Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and this is an extra video because the last video about reaction to the whole conversation related to microservices and monoliths following the case study published by the Amazon Prime Video quality something team. You can see in the previous video the whole details. Has got some very interesting reactions, and I'd like to go through a few of those and also through another very interesting article talking about this same topic. So yeah, thank you so much to everybody for joining this conversation, and I hope to see more of you. Here are some of the reactions that I got. First from Lucian Adrian, who is somebody I know working in Bucharest, and I've been collaborating with him from time to time on various things. To be back, one is to leave. Have they left at any point? Talking about monoliths, and of course, and then Thomas Sundberg, something similar. Were they ever gone? Of course, monoliths were never gone, and I understand that I gave the title to this past video, Are Monoliths Back? Which was, of course, a bit provoking. Maybe not the best title, but sometimes for YouTube you need to create titles that are provoking a bit of thought and reactions. Also, I'm not the best of giving titles for these videos, so yeah, it is what it is. Anyway, my answer was not at all, but there's the reasonable way to discuss architecture. And as I discussed in the beginning of the video, the reactions to the original case studies show that it hit a cultural sweet point. Technically, the case study is a brilliant example of an iterative approach. And this is one of the main points that I tried to make in the past video, which was that on one hand, the case study is just brilliant in terms of iterations and in terms of how you should approach architecture without bias, or with at least bias possible, and just focus on, the first problem that you're trying to solve, and then the next problem, and then the next problem. And when going through these steps, you'll figure out at some point that you need to do something different. And this is when you do architectural refactoring, because basically what they have done, they don't write this in the case study, but you kind of get it from reading between the lines, that they started with services and with a serverless approach, but many of the things, I think they mentioned at some point that they deployed using containers. So then moving back to a kind of a monolithical approach, which actually sounds more like a core plus plugins architecture, given the end of the case study. That was probably not that difficult, since if you start from a modular approach, then it's easy to recombine the modules into a monolith. The big problem in architecture is doing modular, is finding the modules, going through a modular approach. And so technically, very interesting case study. It's something that you should think about, I think. If you are involved in architecture for your products in any way, learn as much as possible from this, because it is a brilliant example. But the reactions to the original case study were very weird, and the only reason why they were weird because it was a cultural problem. microservices have been touted as the solution for a lot of things, and many people have associated Amazon with microservices. And some people would say that this was their PR and their marketing and so on. But honestly, if you go through the materials from their conferences, through their technical materials, what they are saying often is what we want is to put the customer in the center, to give everything they need, everything you need to the customer. It's a very customer-centric approach. And in doing so, of course, you do trade-offs while doing the architecture. So I don't think that Amazon is pushing for everything to be serverless or everything to be microservices. They are showing advantages on this. Maybe they don't do such a good job of showing the disadvantages, but on the other hand, that's the job of an architect, right? Look at the things that are the possible solutions, the possible infrastructure, the existing libraries, the existing ecosystems, the existing reusable things that you can use for your architecture, and decide which ones make sense and which ones don't, depending on where you are in your development process and depending on the trade-offs that you are currently struggling with. So I won't blame AWS for declaring and talking a lot about serverless and so on, because of course they do. It's one of the good solutions for a very fast development. But it doesn't mean that it's a perfect solution for everything. And I don't think you will find anywhere that in their materials that it's the only solution to any kind of development. So yeah, we need to think a bit more, and what I like to do is to see more nuanced conversations around this topic, and this is kind of what I try to do. And then I got another reply from John, which I'll go back to in a minute. The next reply came from Dumitru Pașcu. He is an architect that I worked with as one of our customers. And he points out to something very interesting. Our industry as a whole still doesn't understand that iteration is the best way going forward, regardless if you use microservices or monoliths. Also, many times we use microservices for the wrong reasons. Both monoliths and microservices are here to stay if used correctly. Absolutely. And I think my reply to his tweet was, yeah, that's a very good summary of my commentary on the whole article and reactions to the case study. And now let's go back to this. Indeed, good story. Liked also this piece from Werner Vogels, a person who knows a thing or two about architecture. And so I thought about how about we go and look a bit at the article by Werner Vogels. In case you don't know, Werner Vogels is Dr. Werner Vogels, CTO at Amazon.com. He is, as he's saying, as one of the forces behind Amazon's approach to cloud computing. He is one of the speakers, obviously, at all Amazon conferences, and I've enjoyed watching many of his talks, because they are very practical and in nature and very focused on the main principles guiding this style of architecture. So it's very interesting to listen to his talks. Anyway, and now let's look at the article that he published. Monoliths are not dinosaurs, published on May 5th, which is a few days ago. And I imagine this is a reaction to the whole reactions. And it starts with the cartoon with three dinosaurs looking at some computers and saying mono or micro will all be dinosaurs someday. And here's what he's saying. Building evolvable software systems is a strategy, not a religion. And revisiting your architectures with an open mind is a must. To me, I think this is one of the hardest things that I've noticed with architects. It's easy to find an initial solution. It's difficult to disassociate yourself from the solution that you found. So this type of, let's say, egoless architecture requires a specific discipline of intellectual honesty. So you need to look at what decisions you made, what were the results, and then realize, oh, we've actually learned more since the last time I made this decision. I didn't have full information back then. Hindsight is 2020. So if I were to go back now, I would know much more, so I would make a better decision. But what's difficult is to actually revisit your architectures with an open mind. Software architectures are not like the architectures of bridges and houses. After a bridge is constructed, it is hard, if not impossible, to change the way it was built. Software is quite different. Once we are running our software, we may get insights about our workloads that we did not have when it was designed. And if we had realized this at the start and we choose an evolvable architecture, we could change components without impacting the customer experience. My rule of thumb has been that with every order of magnitude of growth, you should revisit your architecture and determine whether it can still support the next order level of growth. Yeah, this is something I was saying in the previous commentary. Scale changes everything. 10 times the scale changes everything. So you need to revisit things. A great example can be found in two insightful posts written by Prime Video's engineering teams. The first described how Thursday night football live streaming is built around a distributed workflow architecture. The second is a recent post that dives into the architecture of their stream monitoring tool and how their experience and analysis drove them to implement it as a monolithic architecture. There is no one-size-fits-all. We always urge our engineers to find the best solution, and no particular architectural style is mandated. Obviously, if you hire the best engineers, you should trust them to make the best decisions. I always urge builders to consider the evolution of their systems over time and make sure the foundation is such that you can change and expand them with a minimum number of dependencies. Event-driven architectures and microservices are a good match for that. Yeah, so this is one of the key things here. With event-driven architectures, and particularly with microservices that communicate through events, what you get is a foundation that you can change. That is, if you correctly identify the modules, because these microservices need to be modules in your architecture. However, there are a set of services that always contribute to the response, have the exact same scaling and performance requirements, same security vectors, and most importantly, are managed by a single team. It is a worthwhile effort to see if combining them simplifies your architecture. Yes. So I think these are very obvious things. We shouldn't be stuck into saying we want to do microservices or we want to do monoliths. What we want to do is obtain a good customer experience. What that means depends on your product, and you need to define it really well. But starting from there, you get a bunch of technical or actually architectural concerns that require you to make trade-offs, and then based on those trade-offs, you need to change things. Evolvable architectures are something that we've taken to heart at Amazon from the very start, evaluating and re-architecting our systems to meet the ever-increasing demands of our customers. You can go all the way back to 1998, where a group of senior engineers penned the Distributed Computing Manifesto, which put the wheels in motion to move up Amazon from a monolith to a service-oriented architecture. In the decade since, things have continued to evolve as we move to microservices, then microservices on shared infrastructure, and as I spoke about, event-driven architectures. The shift to decoupled self-contained systems was a natural evolution. Microservices are smaller and easier to manage. They can use tech stacks that meet their business requirements. Deployment times are shorter. Developers can ramp up quicker. New components can be deployed without impacting the entire systems. And most importantly, if a deployment takes down one microservice, the rest of the system continues to work. When the service comes back online, it replaces the event it's missed and executes. Oh, so it's actually using some kind of event, what's the name? Storing the events and then replaying them. Cool. It's what we call an evolvable architecture. It can easily be changed over time. You start with something small and allow it to grow in complexity to match your vision. Amazon S3 is a wonderful example of a service that has expanded from a few microservices since launch in 2006 to over 300 microservices with added storage methodologies, policy mechanisms, and storage classes. This was only possible because of the evolvability of the architecture, which is a critical consideration when designing systems. However, I want to reiterate that there is not one architecture pattern to rule them all. How you choose to develop, deploy, and manage services will always be driven by the product you are designing, the skill set of the teams building it, and the experience you want to deliver to customers, and of course things like cost, speed, and resiliency. We talked a little bit about complexity as well in the previous video. You need to take into account the operational costs, and you also need to take into account the complexity of operations, because based on the complexity of operations, that can raise various issues related to, particularly to reliability. So, yeah. For example, a startup with 5 engineers may choose a monolithic architecture because it is easier to deploy and doesn't require their small team to learn multiple programming languages. Their needs are fundamentally different than an enterprise with dozens of engineering teams, each managing an individual subservice, and that's okay. It's about choosing the right tools for the job. There are few one-way doors. Evaluating your systems regularly is as important, if not more so, than building them in the first place, because your systems will run much longer than the time it takes to design them. So monoliths aren't dead, quite the contrary, but evolvable architectures are playing an increasingly important role in a changing technology landscape, and it's possible because of cloud technologies. Yeah, so my take on this in the end is, and if it's something that you should remember from this whole conversation, is that first of all, you need to have a very clear problem in mind and to have very clear trade-offs when you move into defining an initial architecture for a product. Secondly, try to figure out the modules and then decide how to deploy the modules. You could deploy the modules in a monolith as a namespace. You could deploy them as libraries. You could deploy them as services. But the important thing is to figure out what are your modules. Because what you'll do after that is you'll keep playing around with those modules. Maybe you'll merge some of them. Maybe you'll split one module into multiple modules. Maybe you'll move some responsibilities from one module to another module. Maybe you'll change the deployment module way for one or more modules, so switch from services to in process, or any number of variations here, right? And there are so many options in terms of deployment, right? We can deploy basically inside a monolith as a namespace. Ideally, it would be if you use a programming language that supports modules with strong boundaries. That would be the ideal way. Build modules that have strong boundaries and then deploy them not as namespaces, but as actual modules. Something that we are beginning to do in languages like C++ and in Java. So you can do something like that. Or you can use libraries, or you can use local services like operating system services. Or you can use local executables that you start from time to time. Not so used because it's easier to do services. Or maybe you can do distributed services, large or small. Okay. But the key here is to figure out which are the modules, what are their responsibilities. Because if you pick the right modules, or more or less the right modules, you'll never pick 100% the right modules from the beginning. You can then recombine them based on the needs that you have in the future in your architecture. And so, yeah, you can start with an approach that uses microservices with event-driven architecture. That's perfectly fine. But it is much more complex and it might be more costly in terms of operations, depending on your workloads and on your operational model. Or you might start with a modular monolith. Again, something that's possible. Key here is not so much the details. Okay, details are important, of course, because they influence a lot. But the first focus should be on what are the trade-offs. And let's figure out which is the thing that's approximating the most what we want from this product. And be certain that you will need to revisit it, because you will. Okay. All right, so this is it from me today. This is just a little extra video. We'll still have a regular video on Saturday. And if you have any comments, let us know. We love comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.